one I didn't type up because it was too long. These are right out of your quiz. It's going to be due this Thursday at midnight. Okay. So remember the Sentinel? We were learning about Sentinels, Sentinel controlled loops, where you type in a number to end the loop. Okay. So which is false? A Sentinel value must match one acceptable input value. A Sentinel value indicates the end of data entry. Well, that kind of sounds true to me, right? Sentinel controlled iteration is often called indefinite iteration because the number of iterations is not known before the loop begins. Yeah, that's true. You don't know. You just keep inputting until they put in the Sentinel, which we were using like -1 or something, right? Or a negative number. So most of you said it's this one. The Sentinel must match one acceptable input value. So that's false, right? You want to make the Sentinel something that they would not enter, like a -1. If you say input positive, all the positive integers, but -1 to stop. So you got that one right. Hey, Karen. Good. Okay. So you guys got the first one right. I'll let Karen and everybody else. Let's see, you guys log in here. I won't close it out yet. Let's see, can I launch this without closing the other one? Let's try it. Oh, this thing is kind of long. All right, we got it there. Which of the following is false? Augmented assignments abbreviate assignment expressions in which the same variable name appears on the left and right of the assignments, equal sign, as does for number in 1, 2, 3, 4, 5, total equals total plus number. So you guys remember what augmented assignment was, hopefully. That kind of looks true to me. The statement f equals f exponent 3 may be replaced by the more concise augmented assignment statement f star equals 3. And the following code re-implements the for statement. And Richard, one second, got it? In part A, using an addition augmented assignment plus equal for number in 1, 2, 3, 4, 5, total plus equal number. Or all the above statements are true. Right. Okay. So we know this is augmented assignment, right? If I say x equals x plus 1, I can rewrite that x plus equals 1. That's the same thing. Okay. So which one of these looks false to you guys? Sorry, admit all. There we go. For you guys that just got in, here's question 1. You're going to see this on your quiz, which is due this Thursday at midnight. Admit. So this was the right answer. A Sentinel value must match one acceptable input value. That's false. Because remember, the Sentinel should be a value that's not something that you normally input. Like if I say input input a positive integer between 5 and 10, type in -1 to quit. So -1 would be something that you would not normally input. Okay. So that's question 1. And then here's where I'm going to end this poll now. And here's poll 2, which is false. And you guys are saying this one is false right here. Why is this false, would you say? You're right. What should it be? If I was going to make an augmented assignment, if I say f equals f exponent 3, how would I write that augment? if I say x equals x plus 1, and the augmented is, Aaron, is just putting the plus sign in front of the equal, what should I do here?
Well, I think it could be 2 asterisks
Yeah.
and then equal.
Yeah,
Do we?
yeah, that's the augmented, right? You just take this thing and put it in front of the equal sign. You took the plus and put it in front of the equal sign here. Same with multiplication, right? If I say x equals x times 5, I could rewrite that how? X
Well, asterisk equal 5.
equal 5, yeah. Just put this in front of it. And same with division. X equals x divided by 7, say. We could rewrite that x,
Which isn't equal 7.
yeah. Right. These are all the same. Augmented assignments. Okay, good. All right. So that was the one that was incorrect. Okay, and now let me share my laptop here with you and for my third question. That's actually question 2. All right, so look at this question right here. This is our third. This is right out of your quiz again. Which of the following statements is false? Okay, this part A is one whole question. The following code totals 5 integers in a list. So we initialize total to 0, and then we say for number in this list, 2 minus 3, 0, 17, 9, total plus number. Okay, is that false? Or an iterable is an object from which the for statement can take one item at a time until no more items remain. Okay, so that kind of looks true. The sequence to the right of the for statement's keyword in must be an iterable, which this is. And one of Python's most common iterable sequences is the list, which is a comma-separated collection of items enclosed in square brackets, which this is. So which one seems false to you guys? A, B, C, or D? One is false. One's not going to work.
Yeah. Doesn't it restart the list, or am I still way off? That's why it seems wrong to me.
Which one are you saying?
Sorry, B. B is true?
B, actually, B is true.
Okay.
I'll give you that. Does anybody see anything wrong with A?
Has to be total equals total plus
Yeah, yeah. You can't just say total plus number. You gotta set something equal, right? So this would be, you should change this to, I'll just change it right here. This would be right. Plus equal. Right? Now you're saying total equals total plus number. Just like we did up here. Augmented assignment. Okay? So this, when you see this, this is the wrong one. Is A. A is false. Okay? Good job, Nicole. Excellent. Okay. So here's our objectives for today. I want to take a peek at Module 5 Lab, which is due this Thursday at midnight. Let me scroll up for a second. What is due this Thursday? Okay. What is due Thursday? We got a lot due Thursday. The Module 4 and 5 quiz, which I've been giving you. You've already got 9 answers if you've been coming to class. And then on Thursday, I'll probably give you 3 more. Module 5 assignment, that's exercises 3.1, 3.3, 3.4, and 3.7 from your online textbook. So this is chapter 3. Those aren't too hard. We've already done something similar in our group exercises. We got the module 5 lab, which we're going to look at right now, just briefly. And then we have the module 5 brainstorm. And remember, for the brainstorm, you don't have to record or video anything. You can just reply with text, just type it, okay? Remember, there's no class due next week. So all of next week is off, no classes. So we do have some stuff due a week from, 2 weeks from today. Okay, so you can't just snooze during spring break and not do anything. We have the DITEL and DITEL. We're getting into functions now. That's chapter 4. So you got 3 little exercises, and then you have the hot dog cookout lab. Okay, and basically I've given you the pseudocode. You have to convert it into Python code. Okay, it's not that hard. We're gonna look into that more on this Thursday, so you'll know what to do. Okay. So anyway, so for this Thursday, you have all this stuff to do right here, which isn't that bad. Okay, let's first look at Module 5 Lab a little bit, just to make sure you guys understand what you're supposed to do. Okay, so that's our objective for today. What we're going to do in class today, we're going to look at Module 5 Lab. We're going to review a little bit about formatted print statements and how to right-align them. And then we're going to get into functions, which is really cool stuff. You're going to like that, I think. So let us dive into what you have to do for Lab 5. This is a Word document. You need to download it. And we're talking about condition-controlled loops, which are while loops. And this is just some more reading. And then what you need to do is fill in this stuff right here. That's the blanks, okay? So you're going to be editing, and right here it says, in the space provided below, create a loop control variable named keep going of the data type string, initialize this variable to y. So we already did this, right? It's going to be
Keep going.
equals y in double quotes.
Yeah,
right?
double quote y.
Right, exactly. Okay. And then right here, this is pseudocode again. We're declaring 4 variables: monthly sales, store amount, imp amount, and sales increase. Okay. So this is how you do it this is how you declare variables in pseudocode. How would I do this in Python? How would I declare monthly sales in Python?
The monthly sales equals 0.
Yep. That's all you do. Set each one equal to 0. So you get rid of these. Declare real. We don't need those words at all. All you do is say monthly sales equals 0, store amount equals 0, and amount equals 0, sales increase. Okay. And then now we're going to have our while loop. You just need to fill this in here. There must be one more variable here. I forgot. What did it say? Oh, okay. So this is we're doing this again. So this would be keep going equals yes. And then while, what? While we're gonna loop. This is the while loop in pseudocode. It's got while and end while. So we set keep going equal to yes. So while
Keep going.
equal yes.
Double quote y.
Double quote, yeah, that goes there. And then this is a while loop, so we're gonna loop once that's true. So that's true because we set it to yes here, so this is true. And then we're gonna put our code to get the monthly sales. We're gonna stick it in here. In here, we're not actually gonna do that. All you have to do in this part is just fill in these blanks. And then it's prompting you, do you wanna run the program again? Enter Y for yes. So you're just gonna say input keep going. All you have to do is put keep going here. That's pseudocode for asking the user to put in a value. Okay, you just say input and store that value and to keep going. Okay, so that goes there. And I think that's the end of this part, and then you gotta write the bottle program. Let's see. Okay, we just did this. Oh, this is, oh, my bad. You're gonna do the same thing here, but this is a do while. It's a little bit like a while, but if you say do all these things while this is true. So it's almost exactly the same as before, except instead of while, end while, it's do while. So you're gonna execute it at least one time. And then here you're gonna say input keep going, and then here you're gonna say while keep going equals yes. Okay. Now we get into our bottle program. This is a count controlled loop. We're gonna, and I think I showed you guys what mine looks like when it runs. So you're gonna prompt the user. So this is gonna be a Python script you're gonna write. And they're telling you exactly what to do here. Okay. You're gonna create a variable called total bottles that initialize to 0. Okay, so it's gonna be total bottles equals 0. That's this is initializing. This is what we have to do in Python. We don't say declare int total bottles. We just say total bottles equals 0. It knows that it's an integer as soon as we've assigned 0 to it. So you're gonna create a variable called counter, initialize that to 1. You're gonna create another variable called today bottles, initialize to 0. You're going to create a variable called total payout, initialize it to 0. And then a variable called keep going, initialize to the string y. Okay, and now you're going to fill in the pseudocode down here. Make calls to the following sections of code under the documentation for step 2. Okay, so you're going to declare your variables right here. Total bottles equals 0, today bottles equals 0, counter equals 1, keep going equals yes. What else was there? Total payout is 0, yeah. Okay. And then, do you want to enter, so then we're going to put the code in here to get the total bottles, calculate total payout, and then ask if they want to keep going. They say yes or no. This is a sentinel. So you're going to say input keep going here. And then here's your code. You just got to fill in this stuff right here, which you've kind of already done. It says declare and initialize total bottles, today bottles counter to 0. Oh, counter should be, wasn't counter set to 1?
Counter set to 1.
Counter is initialized to 1. Okay, so this is a little bit wrong here. I mean, you could set it to 1 or 0, it doesn't matter. But I would set it to 1, it's easier. And then you got number of days equals 7 here. So this is a constant since it's all caps. So now you're going to loop, this is a whole nother program, the bottle collection program. You're going to loop 7 times, right? So while you're going to say count is less than, I would set count equal to 1. And then while count is less than number of days, that's going to loop 7 times. It's going to start with 1, less than or equal to 7 actually. So you're going to say while count less than or equal to number of days. Do all this. Hi.
Less than or equal to number of days.
Yep, less than or equal to. If you start it with 1, right, it's going to be 1, 2, 3, 4, 5, 6, 7. If you use strictly less than, it's going to go 1, 2, 3, 4, 5, 6. You want to, basically you want to loop over the 7 days of the week. Okay. So you're just going to fill all this stuff out. Here's your count payout. We've got another constant here in capital letters, a variable that's a constant, and it's set to 10 cents. That's how much you get for each bottle. So you're just gonna, this is gonna be pretty easy. I'm not gonna give you that, you guys can figure that one out. In the pseudocode below, write the missing lines. Now you're just printing out, you're just printing what you need to print. And now we got the actual, now you're gonna really write the whole program in Python down here. This is kind of reiterating what you just did, and this is what the program's gonna look like when it's run. Enter the number of bottles for day 1, and you put numbers in for day 1, 2, 3, 4, 5, 6, and 7. These people collected a lot of empty bottles. 346, so, and they get 10 cents each, right? So you're just calculating for each day, they've got so much, and then the total number of bottles collected is this number, which is the sum of all these. And then the total paid out is the sum of all these times 10 cents, really? So you can see it's, you just move the decimal point over 1, so it's 458.2. Do you want to enter another week's worth of data? Enter yes or no, they entered Y, and it's just gonna prompt them again. Okay, so that's due this Thursday. So any questions about that? Yeah, cool.
Do we have to do, so it's the top one included in the second one?
Mhm.
If not, like two separate?
No. Yeah, the top one's just kind of reviewing the last thing we did, but using a while instead. The last exercise we did. And this is this bottle collection thing is brand new.
So which one? So which one?
So you turn in the Word document all filled out with all the blanks, and then you're gonna turn in the Python program for collecting bottles.
Oh,
Does that make sense? It's a good question. Yeah, upload the Python script, yeah. Because I'm just gonna grab it, pull it into VS Code and run it. Yeah. Okay, so this is the second time we've looked at this, so you guys should do well on this. All right. Any more questions about the last? Okay, very good. All right, so we've looked at this. We're done with this first thing here. So now let's review formatted print statements, and then we're going to get into functions. So it seemed like some people were not quite clear, and that's probably my fault for not going over it clearly enough for you guys. So here's a regular print function. If I just say print hello, single quotes, okay? So this just prints out the word hello, the string hello, and then it prints a new line. So if I printed this, then it would be ready. It would be ready to print something out on the next line. Okay? If you type this into your terminal, after you already invoked Python, this is the interactive terminal. You would just print out hello, and then the cursor would go and be waiting for your next input. So how do we print a formatted string, and why do we even do that? So we'll suppose that we're in the interactive shell, and we say x equal to 5, and we want to print out the value of x. So we're going to do it in a formatted print. So the difference is we use print, and we put a little f in here, and then we put our string, whatever we want our string to be. So we could just say hi, or we could say hello, whatever. But if we want to get the value of this variable x, we put it in curly braces, x. Okay? So this is called a formatted print. And this is going to output hello with a space, because we have a space there. It prints out just like it is here, hello and 5. Okay? So this is what we call a formatted print. So we can put the value of the variables right inside here. Okay? The other way we could do this, which is the clunkier way, we could say print hello, and no space, and a comma, and we could print X. That would do the same thing. It prints out hello, and then automatically puts a space in, and then prints out the value of X. So this would print out the same thing. Hello, space, 5. But I like this method better because you can see exactly what you want, and then you can format that. Okay, so you can make it right aligned within so many spaces. So let's try that. We're going to print out hello, and then a space, and then we're going to print the variable X. But this time we're going to right align it. So we put a colon, right align it in, let's see, 1, 2, 3, 4, 5, 6. We'll put it in 10 spaces. So what the heck does this mean? We're going to print out 5, right aligned, because it's a greater than sign, in a total of 10 spaces. Okay? So this is going to print out hello with a space, and then 10 more spaces. And it's going to print the 5 right here. Way over there. Because I told it, print out hello and then X in 10 spaces. Okay? Does that make sense? So this is 10 right here. You can try it and see if it works. Let me type it in and make sure it works. Let's pull up. Okay, let's exit this thing for a second and clear this.
Did you want you wanted the F in there for the format?
Print format, right? Did I skip the F?
Yeah.
Oh, my bad. I said hello, space, colon X. Let me make this bigger so I get. And then greater than 10. Oh, and I forgot that, didn't I? Okay. Did I forget to put the F? Yeah, good catch. Yeah, so the F has to be right in front here. A little bit. Okay, so you can see when I printed it out, I can't count the spaces, but there's really 10 here. 2, 4, 5, 6, 7, 8, 9, 10. Okay. So, what if I wanted to print a number with a decimal place? I know you guys probably can't read this in the back, it's getting small now for you guys. So if I want to print the decimal place, I'll do a formatted print, and I'll say hello, and a space, and then I'll print in curly braces X colon point right aligned 0.2F. Okay. Okay. So this is going to print that with 2 decimal points right aligned. It should. Let's try. Point 2F. Oh,
Hello.
I didn't put 10.
Hello.
I didn't put 10. Hang on. There it is. Okay. So what this one did, and this is how we align all the decimals. This next one printed, oh, and I forgot the 10 here too. Dummy. Okay. X right aligned in 10.2 F for floating point. Okay, so what this one does, I'm just going to write it over here. It prints, and it's still 10 spaces, but it prints oops, it should be actually right here, 5.00. So it's printing 5 out, right justified within 10 spaces with 2 decimal places. So the reason we would use this, like was in our group project that we did last Thursday, and we wanted to align all the numbers right aligned, that means all the if I do this with everything, all the decimals line up on the right. Even if they're, you know, say it's 5.00 and 132.25 and 4,006.75. All those will line up on the decimal place if I right align them like this, which is kind of nice. That's how you want to see numbers like that. Okay, so formatted print. Formatted print. Maybe I covered it a little better this time. So any questions before we move on to functions? Is that too low to see? A little bit? I know, because you guys are sitting down here and trying to look over your monitors.
Oh, I have a quick question.
Yeah.
I'm curious about what will happen instead of using the greater than symbol for going to the right. What
Yeah.
if you like the
Less than?
Yeah, would that to go to the left?
Left,
or
yep.
left
Sure
over?
does, yep.
Oh.
Yep. And in this case, you could try it. If you put the less than here, it's going to pull it over right to the left. It won't overwrite this, it can't, so it's going to start it right there.
Yeah. I was curious about that because I was testing it and I was curious about if it would override the hello. Is
No.
what I was curious about.
It shouldn't. Try it.
Yeah.
Try it out. Did you try it?
Yes, and it
It-
always stops.
It starts right there, right?
Yeah.
The 5 should start, if you did the
Wait.
less than, the 5 should start right.
Yeah, right after the hello.
Yeah.
Yeah, it does do that.
Yeah.
Okay.
Okay? Yeah, so formatted print's really nice. I mean, this is a pretty cool way to do. With all this little statement here, you can do a lot. You know, you're saying, I want to print the value of the variable x, right aligned in 10 spaces, and have 2 decimal points after the value of the variable. So it converted that integer to a float, put 2 zeros there. So it's pretty powerful. That one little statement's pretty powerful. Whoops. Sorry guys, let me let you in. Okay, cool. Good, we are doing well on time. All right, let us get into functions now. Okay. So here's a couple of things about functions. Let me erase this stuff. So now we're getting into like some real powerful programming concepts. Writing your own functions. We've already used functions. You guys have used functions already. The
Built
print,
in.
print is a function. Min is a function. Max is a function. Average or mean, mode, median, those are all functions. We've used those already. When you're developing a large program, it's better to break it up into small, more manageable pieces. This technique is called divide and conquer. Okay. So we can use existing functions as building blocks for creating new programs, and that's a key aspect of what we call software reusability. So we don't want to have to reinvent the wheel every time. So if I have a function, like say I wanted to print out something like the sum of 2 numbers. So say I said, let's get num1, I'll say equals int input enter and integer space and that and that. Okay, so there's num1, and then I do the same thing with num2. So I've just prompted the user to type in two integers. And I've stored their values in num1 and num2. Okay? And then say I wanted to print the sum of those two. Add them up. I could do a formatted print, of course. And I could just say sum of num1 and num2 is equal, and here I can just put the arithmetic right here. Whoops, it's num1, sorry. Num1 plus num2. Okay, I could just do that, right? This is another good thing about the formatted print. You can put expressions in here instead of just variables. Now, suppose I wanted to do this 100 times. Without a for loop, I would just have to write this print statement again, the whole thing, over again, 100 times if I want to do it 100 times. Right? If I want to prompt the user for two numbers and report the sum and do this whole thing 100 times, right? What would be an easy way to do that? If I wanted to do this 100 times and prompt the user for two numbers and just print out the sum. Would I put it inside a for loop? Yeah, right. That's one way to do it. I could just say for I in range 100, this is indent, these are all indented, and I would just print the sum, and this would just prompt the user to enter two numbers, print out the sum, do it again, do it again. So this is one way to kind of reuse software where I'm not writing out something 100 times. Now, a function is almost the same thing as what we're doing here, where you're passing in a value and you're doing something, right? We're doing something 100 times, okay? So we can write our own function, and then let me show you what it looks like in pseudocode first. They call it a module, and you would say. Let me see here. Yeah, it's just module and in module. Okay, so this would be this is pseudocode for a function or what they call a module. Pseudocode, and this would be called modular programming. We're going to write pieces of code that can get called over and over and over again, so we don't have to repeat the same code. Okay, so you would say module. Whoops, module. And we're going to call it show message. Okay, and inside here we're going to just display hello, and then we're going to say in module. Okay, so this is pseudocode for a module. So we've written our own little module or function right now. It's very, very simple. All it does is display the word hello. And then since we've written it, that doesn't invoke it. We have to do a thing called calling it. So if we want to invoke this, in pseudocode we say call show message. That invokes it. So we defined it. This is the definition. This is indented. This would be the body of the module. Okay. And now this calls it, this executes it. executes the module. Okay? So if we want to display hello, we want to print hello, all we have to do is call this function show message. And anywhere in the program we can, if we don't have to rewrite this. We've already written it, we just have to call it. Okay? So this saves us a ton of time. Right? So we're not duplicating possibly lengthy code where we're doing a whole bunch of stuff. That makes programs easier to modify. When you change a function's code, all the calls to the function execute the updated version. Okay? So if we wanted to change this, instead of saying hello, we could say hello world. We just change it in one spot. Right, now this is still the body. And then every time we call show message, it displays hello world instead of hello. Okay. So let's get into a little more functions. So by the end of today, I'm hoping that you guys will be able to create your own custom functions, import and use Python standard library modules such as random, I don't know if we're going to get to random today, and math, to reuse code and avoid reinventing the wheel. Pass data between functions. Generate a range of random numbers. We might not get to that today. Learn simulation techniques using the random number generation. We're going to get to that. Pack values into a tuple and unpack values from a tuple. Some people call it a tuple. So my tuple would look like this. It's just a list of numbers separated by commas, but surrounded by parentheses. This is a tuple. Okay? And we can return multiple values from a function via a tuple. Okay? So in pseudocode, we call a function a module. Here's my same thing that I wrote up there. Module show message. And we have a module in module. And then what it does is inside here. And I spelled hello wrong, didn't I? To execute the module, you write a statement that calls it. Call show message. Okay? So that is pseudocode. All right? So let us write a function. Let me show you how to write one in Python. It's a little bit different, but not much. Okay, let me make this a little bit bigger for you. Make this. Okay, so I've written a program called intro functions, right here. And I have a comment that says introduction to functions, and here I'm going to define a function. So this is pseudocode. This will be Python over here. We're going to do the same thing. So instead of saying modules show messages, we say def, which means define show message. And the naming of functions is the same as variable names. And then we put a colon here. You don't start with a 0, you don't start with a number or a special character, but you usually start with a lowercase letter, and then it could be anything else after that. And then instead of display, of course, you guys know we use the word print. Hello world. And then we don't have to say end module or anything. This is our function definition. And the way we call it is we just say show message. We don't use the word call. We just say show message. And we have to put these parens around it. That tells us it's a function. Okay? So this is all you have, this is this pseudocode converted into Python code. So Python code is a lot easier. Okay? So I've written one called say hello instead of show message. We don't need the period there. So there's my function definition. It's got a colon. it's got two parens, and then I'm gonna make the function call down here. Let me comment this out for a second. Okay, so I just defined my function. If I run this right now, nothing happens. I defined it, but I never called it. So now let's uncomment this and call the function. Okay. And now I'm gonna run it, and it printed out hello. Okay? So that's pretty nice, right? So I could even say I want to call that function 5 times. For I in range 5, I'm going to call my function 5 times. Okay? So I just printed out hello 5 times. Nice and easy. Okay? So any questions about the basic, this is a function definition. And this is the body. This is the body or the block. You could call this the body or the block. Whatever is indented, and this can be a bunch of things, okay? And this would be the call to the function. Okay, so once you define a function, you have to call it in order to invoke it. Does that make sense? Okay, let's take a step further. What if I put a variable in here called my number, or let's say we'll call it my int, equals 5, and I want to print my int inside here. Okay? And let's do this. Let's clear this. So now my function prints hello. It creates what we call a local variable. That's a local variable. And it prints it out 5 times. So let's see. Well, it's going to print it out, and then we're going to call that function 5 times. Okay, so it's printing hello and 5. Let's make this a little nicer. Let's make this a format print. And we'll put hello and then my int in here. This should print hello 5 times. Okay, that's better. All right. So we're getting into a little topic about functions now. This is the definition. We've defined it, and here we're calling it. Okay? This is a local variable. We're getting into something called scope now. This variable called myInt is only visible inside this function. Once you get out of the function, it gets deleted. It's not available.
What?
And it's only visible in here. Okay? So let's try, we're in the function, let's try to print myInt down here below and see what happens. So
Not
we're outside.
indented?
Go ahead.
Not indented?
Yeah, not indented, yeah. So we're going to say print myInt right here. So we're outside the function now, right? The function is only the indented part. Let's see what happens now. Ah, it says name error. myInt is not defined. So we're outside the function. The function's only this inside the block. So we tried to print myInt, which was defined in here. It's just a local variable. It's only local to this function, so we can't access it here. Okay. So that's a local variable. Now, what if I put a variable at the very top of the program? And I say my global equals 10. if I put a variable at the very top, it's called a global variable. And that is visible inside any function. Anywhere, and if I put a global, it's visible inside here. It's also visible outside the function. So let's print. Let's run this thing and see what happens. Okay, we did hello 5 and we printed 10 right here. Okay, let's try to print my global inside of here. So now it's global, so it should be visible inside this function. Let's clear this. And it is. So we printed 5 and 10. So we printed our local and the global all right here. So global variables are at the top, they're visible anywhere. Local variables are only visible inside the function. Okay? And if you ever see a question on global variables in the quiz or anything, they recommend that you don't use global variables. It seems like a good idea, right? It's like, put it there and I can use it anywhere. But it's very hard, if you start using global variables, it's really hard to debug your program. So if you ever see a quiz question about globals, say, do not use them. And you'll get it right. Let's see, what else did I want to show you about functions? Oh, okay. So what are these little, you know we have a print function, right? Like right here. Or we could say print, just like that. That just prints an empty line. Or we could print, and we could put some things in here, some text. Hello, world, bye. Okay. This print function has 3 things that are sent into it. These are called arguments. Okay? It's got 3 arguments. So can we write our own function that takes arguments? Yeah. Let's modify this and we will have an argument here. Let's call it my float, whatever. Okay. So now it's going to take an argument, and when I'm defining the function here, this isn't called an argument, it's called a parameter. When I do the definition, my float, I'll make that capital better. 2 different terms. So when I'm defining it, right here too, this is now called a parameter if it's in the function definition, but when I call it down here, it's called an argument. So I could pass in 3.14. Okay. So let's see how we do that. So there's 2 different, so this is an argument. It's called an argument at this point. Here it's called the parameter. The value here gets passed into that parameter when you call it. There's a 1-to-1 relationship between those 2. So let's create a parameter, call it my float, and let's print it out inside here. Okay.
Instead of my global?
Yeah, instead of my global, just for now. And then let's call say hello with, it's got 1 variable, we'll call it 3.1. We're going to pass in, so 3.14 is the argument. Is the argument to the function. Okay, so now what's going to happen is I'm calling the function right here. This is the function call with one argument. That value gets put into this parameter, this variable,
And
right? This 3.14 goes into my float when I call it here. Okay, and then it says, then we have another local variable, we have two, we have my float and we have my int, which we set to 5. And we're gonna print out, hello, my int, which is 5, and my float, which is 3.14. That make sense? So now we've written a function that has one argument. Okay? And when I call it, it printed out hello, 5, and 3.14. Okay? So, just to see if you guys are following me, what do I call, in this function definition, what do I call this? An argument or a parameter?
A parameter.
Parameter. When I call the function, do I call this an argument or a parameter?
that is an
Argument, this argument. Everybody gets that kind of confused, okay?
Argument.
Okay, we can make multiple parameters here, but they all have to match up with what we pass in. So let's add one more. Let's put it up my Boolean in there. We can pass Booleans. My Boolean. And we'll put, what's a Boolean value?
True.
True. Okay. And let's print it out inside this function, my Boolean. Okay. Whoops. I'm going to give you guys a break in a second. Okay. So now we've got two parameters. My float and my Boolean, and we're passing in two arguments. So the 3.14 matches up with this one, and the true matches up with this. Okay. So when I call this right here, what do you guys think it's going to print out? Hello, 5, 3.14, and
True.
true. Let's see if that's right. Yeah. Okay, I want you guys to take a break so you don't get overwhelmed. So take a break, come back in about 10 minutes. So this is a good introduction to functions. Parameters and arguments, local variables and global variables.
Did you mean to dismiss us for break? Yeah?
Dismiss till 10
Okay.
till, or